There we go. All right. So welcome back to week 3 of the SAS Bootcamp. This is, if you've stuck with us so far, we are halfway through all of the content we have to learn this bootcamp. So you've made a great deal of progress already. We are halfway through there. And really, I think the next week is going to involve some challenging content. But after that, things will get really simple. We are going to have the last 2 weeks are going to be repetitions of what we've already covered using different techniques. And then the final week is actually just a little bit of introductory data analysis. So I want to hear feedback from all of you on how this course has been so far. If you all think it is moving a little fast, one of the things I'm considering is changing the order of the content. Even though I previously distributed a syllabus, I'm considering spreading out the difficult sections a little more so that you'll have more time to digest and work on it for the next 3 weeks. But you are here today, it's halfway through the boot camp, so you've already worked on this a great deal. And I want to congratulate you for being here. And I want to thank you for being here because this is a long weekend and I realize many people are on vacation and you probably cannot join. So for those of you that are here, thank you. Before I move into what we are going to cover today, I've gotten a few questions about this week's content and about the homework this week. Before I go there, any feedback from those that are on the call? Either about the videos this week or maybe the homework?
So I had a question with respect to the loop command, the loop function.
Okay.
I mean, like with respect to social and administrative like data, like what's the use of doing that, while you're analyzing data, coding for data, how do you use that, or why is it used? Like, I didn't understand that when you were explaining.
Okay, that is a very good question. So I wanted to take this week to introduce loops as a concept to you. We did not really go over applications of loops. And I know Shishir asked a question on Twitter about nested do loops as well. And Samuel, your question is very similar to that because we did not cover applications of loops in this week. But that was intentional. I wanted to introduce loops as a simple introductory concept this week. Next week, we are going to take and apply loops to arrays. And you will see that once you apply loops to arrays, loops have so much potential. Everything in social and administrative sciences, from calculating adherence to looking for continuous eligibility to looking for temporality in your data. So if you have use of a medication at a certain date and having a certain disease or a second medication or a certain adverse effect or something else in the data that you're looking at, which are all temporally based, all of those things can be done with loops very, very efficiently.
Okay.
We'll go into arrays and how to apply loops really into the data that we have next week. So that's part of the content we're going to cover in week 4.
Okay, thank you.
But that is a very good question. Thank you. Any other comments from everyone else? I want to hear if somebody thought this week's content was a little challenging. And particularly with regard to reading across rows, those lag, retain, and first and last dot statements, I thought they may have been challenging. I want to know if anybody else thought that too.
Well, I did. There was a little bit confusion in, I think, video 6. So,
Video 6.
Yeah, reading across.
First and last video, Queenie?
Sorry?
Is that the video with the first variable and the first and last dot variables?
Yeah. So we were sorting them by type 1 and type 2. So there was a little bit confusion. I was not able to understand. Like, I think I was lost. But then again, I saw the video, so it was clear. And I just had a doubt. Like, I'm not sure if I'm right or wrong, but so in the exercise for this week, we were using, so you use the where function for the first question. So my question is that does the where function and the proc sort data do the same thing? Because I used the proc sort data and I got the same output as when I use the where function.
Really?
Yeah, and I think maybe I did something wrong, or maybe I'm not able to observe that. But so
okay.
just
That's interesting. So Queenie, the where function is primarily to subset your data. It is to filter out rows and to delete certain rows so that your final data set has fewer rows, right? That's the purpose of where. Proc sort does not delete rows. Proc sort basically rearranges them. It sorts the data set, right? It does not delete rows anywhere. In fact, you can use a where statement within proc sort. And I know I did not cover this during the videos, but you can use a where statement within proc sort to both sort or arrange your rows and filter out some rows at the same time. But I don't think where function and the sort procedure, which that one is a procedure, the other is just a statement, right? So the where statement and the proc sort procedure don't do the same thing. I am not sure how you could have gotten them to give you the same result. I think it depends on exactly what you wrote before and after the where statement as well.
Yeah, maybe.
But
I will try it again using where in the proc sort and let you know. Okay.
I don't think you should try to put where in the proc sort statement. Try to keep working with the where statement within data step like we've shown so far. You should still see that the result from the data step with the where statement should be very different from a proc sort. But if you still have problems, you can show me what code you're looking at or take a screenshot and send it to me, and I can try and figure out what's going on.
Yeah, I'll do that. Okay.
Okay.
Thank you.
To answer your question, those two things are not intended to do the same thing at all. Very, very different processes.
Okay.
But thanks for your comments earlier too. If you found this was confusing or challenging, I think there is no shame in that whatsoever. Some of this stuff is challenging. I'm not going to deny. I think the only way to get through it is to watch those videos a couple of times and then practice, really. I don't think SAS overall is challenging, but it does take time and it's a steep learning curve sometimes, especially in places like this, for example. Does anybody else have feedback to share about the content for this week? Okay, I'm not hearing anything and I don't want to pick on anybody. But if you do have something, please feel free to interrupt me. That's okay. What I'm going to do for the rest of today is I'm going to review certain things we've covered in the videos already, because explaining things a second time is not going to hurt. And I think I've received feedback that some people could use a second explanation of some of the concepts. And then I want to work through how the SAS program data vector processes reading across rows, because that's one thing that I know is challenging. I've also received a couple of questions from people that could not make it to today's call. So I want to answer those questions and then I want to do the homework. If you all want me to add anything else, include any more content in this discussion, please let me know. Yeah, not hearing anything, so I'm going to start sharing my screen and we'll jump over into SAS Studio. Okay, the first thing I want to cover today, let me run my libname statement. This is your code for week 3. Okay, the first thing I want to cover today is go over reading across rows one more time, right? I will skip the lag function because I think the lag function is simpler. Let me put it that way. It's simpler than retain or than the first and last variables. So I want to cover the retain function one more time, and I won't go into as much detail as we did during the videos, but I want to cover it hopefully from a new perspective that might help you understand if you still are confused after you watch the videos. Okay, so what the retain function is doing is it goes back to how the SAS program data vector works, right? When the SAS program data vector is processing row after row, it does not know what happened in the row before the row that it is on, or it does not know what are the values in each column in the row after the row that it's on. So whatever row a SAS program data vector is on, it can only utilize values from that particular row to do any of your processes. So if you are using values in a different row, the SAS program data vector cannot get to it. And the way to make that work is to use the lag function or the retain function. And the retain function is really neat because it lets you hold on to what was the value of that variable in the previous row within that same variable over and over again. So as you go from row to row, SAS simply remembers what was the value of that variable in the exact previous row, right? And then when you go back down to the next row, it updates that value for every single row. This lets you create this incremental process with a variable that you cannot do if you don't have a retain statement. So in our example here, where we use new ID equals new ID plus 1, what we did basically was we set new ID to 0 for the very first row. We set new ID to 0 before we started processing it. And then we incremented new ID to 1 for the first row, and then 2 for the second row, 3 for the third row, 4 for the fourth row, and so on and so forth. And we incremented it for every single row. And we could only do that because SAS can help remember what SAS program data vector can remember the value of that variable in the previous row, and then constantly update that number it is remembering for every single row it is processing through, right? And that process of updating is what lets us do this. So in this example, I'm going to run this one more time just to show you guys. In this example, we went from 1 through however many rows we have in this data set, and we could only do that because of SAS program data vector's ability. Now, the real strength of retain, though, is not in doing that, because this new ID equals new ID plus 1, where we just added a column with all of the row numbers, is really not useful, because the row numbers are already stored in SAS in a hidden variable, which we've talked about elsewhere, which is called _n_. That's the variable that's usually not shown in a data set, and it's equal to the number of the row. And you can use it if you want the ID number like we've created right here, without having to do all of these things, right? So retain is powerful, but retain is not powerful when used alone. Retain is most powerful when you can apply it using first dot and last dot variables. And let me show you why that is. I'm going to share this whiteboard screen here. Can you all see my whiteboard right now?
Yes.
Yeah.
Okay. So I want to demonstrate. I'm using my fingers again, so this is a little more crooked, but please bear with me. So let's say you've got a variable A, B, and C, and using the retain function, what we've done is we've incrementally gone down this column, and we've done 1, 2, 3, 4, 5, 6, and we were able to go increment it by 1 every single time because we added just the value 1 to it, right? So from here, it started out at 0 before the data set began, and we added +1 to it here, and then +1 to it here, and we kept doing that. Now, if you want to make this more interesting, which in most cases in data sets, that's what you will want to do, you might not want to add 1 to it, you might want to add a different value here. And the value you might want to add may be the value of the variable B or the variable C, right? So every single time when it goes to the next row, it remembers what happened in the previous row, and then adds the value of B in the new row to this number to create this value, right? And then that gets remembered to the next row, takes the value of B or C here, and then adds it in to that row, right? So for every single row, we can incrementally add or multiply or do whatever mathematical process we want, and we do it incrementally. The simple example I showed you was where we just added the number 1, so it looked like we just created the row number variable. But you can make that very interesting, and you can basically carry it forward from the beginning of the data set to the end of the data set. And this is interesting for many reasons, right? You want to see this incremental processing perhaps occurring throughout all the rows in a data set. But really, the benefit and the strength, the potential of retain statement is in not processing the whole data set, but it is in processing parts of a data set. So let me see if I can clear this. Start again. Okay. So let's say, for example, that we've got the same thing, right? We've got variable A, variable B, and variable C is what we are creating. Let's say variable A is the individual's ID. So we've got individual 1 here. And I'm going to say we have individual 1 4 times, individual 2 in here twice, 3 is in here once, and 4 is in here twice, and so on and so forth, right? I'm basically using the same example as earlier, but now we have repeated subjects, which most big data and even most repeated measure surveys, for example, will have each individual survey response on a separate row in the data set. And the strengths of SAS are being able to collapse them together and obtain the summary variables and the summary distributions that you want. So to do that, we want to use the retain function. We want to be able to use the retain function to go across different rows, but we don't want to go across the whole data set. We want to be able to go and cut that retain function off wherever we are interested to create these little groups or buckets. And I keep using the word buckets when we talk about that, when we were in that, in those videos, for example. But really, some people call them groups, some people call them subgroups, some people call them repeated measures, whatever you want to call it. We are using the retain function in combination with very simple if and then statements to basically tell this retain statement what to count up to, if you will, right? Because the retain function is incremental. It goes from row to row to row. And at some point, we wanted to say, stop going from row to row here. And I want you to start doing this process again here, where you can go row to row. And then I want you to cut it off again whenever we go from one bucket to another bucket. And then that allows us to create these groups or subgroups of rows across which we have incremental processing. And then these other subgroups where the incremental processing does not continue. And that's a very important feature within retain. The way to leverage that, the way to get this to work right here is to basically say, use simple if and then statements to say, hey, if the name of the individual is changing, then cut it off, right? Now, how do you say it is changing? You can't just write an if then statement and say, if A equals 2, then stop the incremental process, right? Because what if A becomes 3 then? Then the if statement doesn't work. Or then if A becomes 4, the if statement doesn't work. The correct if statement should say every time the name changes. In order for the name to change, you need to remember that we need to do two things first. The first thing we need to do is that all similar names should be together in one place, which means we need to sort the data set, right? If you don't sort the data set, all similar names will not be together and the names will change too often. So anytime we use first and last variables, the first thing you have to do is you have to sort the data set based on the variable that you want to create buckets out of, which explains the proc sort procedure. And then the second thing we want to do is we want to identify some sort of a marker to say after we've sorted the data set that the name has changed. And that marker that we are using are first dot and last dot variables. Right? Anytime you sort a data set in SAS, those first and last variables will be automatically implemented, whether or not you request it. They are hidden variables. They are already in there every time you sort a data set. And then you can tap into them to do what we are talking about here with the conditional stopping of the retain statements incremental processing. Right? So if we use the first and last statements and we can say, hey, if this was the last time, to recap, the first variable tells you what was the first time that an individual occurred in the data set. The last variable tells you what was the last time an individual occurred in the data set. So now going back to your simple if-then statements, instead of saying if a new name is detected, instead you can say if first is detected, which means that individual is occurring for the first time in a data set, then stop the incremental processing and restart it, right? That's what we are saying. And if last is detected, then that's where you need to cut off your incremental process. So we are using simple if-then statements in combination with these first and last variables on a sorted data set to do incremental processing that cuts off after every bucket that we are interested in, right? Does that help at all? I'm hoping this gives you a little different perspective from what I presented on the videos, but I don't know of many more different ways to explain the same concept, so it may have been a little repetitive as well. Okay, I got a thumbs up. I'm going to take that as a positive. It's hard doing this on video without having to see people's faces that where I can actually read if they understand anything or not. But I got a thumbs up, so I'm going to take that as a yes. Let me close this now and we can come back to it. I think it stopped sharing my screen. Okay, so to go back, let's now look at how we actually, so I drew this out on a whiteboard. Let's actually look at it in the earthquakes data set, right? The earthquakes data set was an interesting example of doing this, I think, just because the ID variable in the earthquake dataset is not the variable we used to do those buckets. Right? Whenever you are doing buckets, you need to get creative about what variable you are using to create those buckets. The ID variable, using that as the bucket, is probably the most standard or common case that you will see, but often you will have to use different variables. Let's say you have a data set with 500 different patients, right? And you have patients repeated across different rows, but these patients may also have, some of them may have hypertension, some of them may have diabetes. So you may use the individual's name or their ID as the bucket, but maybe sometimes you will want to use the disease as the bucket. So maybe you'll want to say, what is the average cost of care for all hypertension patients? Average that. And then what is the cost of care for all diabetes patients? And average that. So the bucket we are using doesn't always have to be the ID of the individual in that data set. You need to get creative with what variables we use as buckets. And I was showing the earthquake data set because it precisely does that thing. In this variable, there is an ID in the beginning, earthquake ID, EQ ID, but that's not what we use to create our buckets. Instead, we use the region variable. The region variable has repeated measures, and it allows us to group across regions and summarize the other variables in the data set for each region. Right? In the particular example that we covered during the class videos, not the exercise, we basically said, let's count how many earthquakes have happened in each region. And I'm going to comment out a little piece of the code from this one so that we can look at what I'm talking about. I know this works because this is the same code I used in the video. I say that, and I think there is an error. Well, yeah, there is an error because I did not run the proc sort before it. Okay, now it ran. So if you look at this now, let's see. That's my sort procedure. So the data set is sorted. Now I want to run this one. Okay. So this goes back to what we just talked about, right? The incremental process with retain, and then we tell the retain statement where to cut off the incremental process and restart it. So the incremental process is going from 1, 2, 3, 4, 5, 6 up to 10. Then when we come to a new region, the incremental process gets cut off and it gets restarted. So the count variable gets restarted when a new region is detected. We went from 10 in this row to 1 in this row. And we did that with a simple if-then statement, right? We just said if first.region equals 1, which means if that region is occurring for the first time as you go down the rows in this data set, then set count to be equal to 1. Right? This statement here, where count equals sum of count plus 1, that's the incremental process. And it is only happening when the region is not appearing for the first time. So when the region is happening for the second time in the data set, then you increment it by 1. So we are saying when to use the incremental process, when not to use the incremental process, so that we can cut off that incrementing when we come to a new region and restart the count variable. And then the recount variable goes up until 6, and then the Ascension Island region count variable restarts. And then the count variable restarts again when we come to Baja California, Mexico, because it's a new region. And then because Baja California, Mexico is repeated, the incrementing takes back over, and we go from 1 to 2 to 3 and so on and so forth. And the incrementing took back over there because we had this if-then statement, where we said if first.region equals 0, then count equals sum of count comma 1, right? So hopefully this should be a good repetition of how first dot and last dot variables work. Those if-then statements, by the way, they work because of these first and last region variables, right? This first_region variable, you can see, let me show this example here. Let me show the Andrianoff Island example. You can see that the first.region variable is 1 here, and it is 0 for all other values of Andrianoff Island. Andrianoff Islands, yeah. And then it's 1 again for the Ascension Island region here, and then it's 1 again for Baja California because that's a new region. The last dot variable is the opposite of that. It is 1 only for the last occurrence of that region as you go down all the rows in the data set. So it is 1 for the last occurrence of Alaska Peninsula. It's 1 again for the last occurrence of Andrianoff Islands, and it is 0 everywhere else in between. So we are using these two variables within our if-then statements to tell SAS when to increment, when not to increment. And this can be very, very powerful. In almost every single health outcomes research project I've worked on, there has been at one point or another the need to do this exact process where we had to define groups or buckets and then say, okay, in this bucket, let's look at average cost, or let's look at how many prescriptions these individuals got, or let's look at how many ER visits they had, how many days of hospitalization they had, or some other variable, right? So these grouping, these use of buckets is something that we will use very, very, very frequently. But if you still don't understand this, don't be discouraged, because while I am explaining how to do this using first and last start variables with the retain statement, this is not the only way to create these buckets or groups. In week 5, we will cover ProcSQL, and we will talk about how to do the same exact thing with one line of code. Here, to do this thing, we've used how many lines of code? We did a proc sort first, and then we had all of these lines of code, which is at least 15, 16 lines of code here. Well, I'm counting the comments there, but we've at least used 5 to 6 lines of code without comments to accomplish this. You can do all of this with one line of code in a different process. The reason I'm not showing that first is because I really do believe you need to understand how this works in a data step environment first. And once you know this, we can then go to the shortcut. I don't want to show the shortcut first and then risk you guys not being able to use the long process when you need to. But I will say that almost every single time I've had to use this kind of grouping or buckets, I have not used the retain statement. I've used the shortcut that I will show you guys in week 5. More to come on that later, but hopefully for now, this is a good explanation of what's happening with reading across rows, first and last variables, and the retain statement. I'm going to pause a second to see if there are any more questions. And then I have a couple of questions from people that could not be on the call that I want to answer first. Any questions so far? Okay, I'm not hearing anything. If you have a question, please feel free to interrupt me later, but I'm going to start moving on. The one question I did receive from one of the people that was watching the videos is why are we using that out statement within proc sort, right? And what does it do? Now, in a proc sort, you don't actually need to use an out statement. If you skip this out statement, the procedure will still work, and it will basically just sort the existing data set within SAS. Now, when it sorts that existing data set, it actually rewrites it and it reorders the rows in the data set. And the proc sort procedure is very simple. It's like sorting any data set in Excel, for example. I am using an out option here for a couple of reasons. One, it is good practice so that you're not rewriting a data set. Even for anything as simple as a sort procedure, you really shouldn't have to rewrite a data set. It's okay to do it in some cases, but I prefer not to have to rewrite a data set. The other reason I'm using the out statement here is because what this out statement does is it basically takes this input data set, sorts it, and saves it in this new data set. That's all it is doing. And I've given both data sets the same name because the first one is in a class library, the other one is in the work temporary library. The reason I'm doing this here is because this class library is read only for all of you guys that are watching in right now, right? You don't have access right to rewrite the sort library. So if I don't write the out statement here, it will work for me because I can rewrite data sets in the class library, but you cannot. So I'm using the out feature to avoid any issues where you try to run the sort without the out option, and then SAS will throw you an error and it will say you don't have access to do that statement, right? So the out feature where you sort the data set, but you save the output data set in a different file in your own work library, which you have permission to access and edit them, is a good practice, if you will. So that's the first question I received. The second question I received was, why do you need to sort before you use first and last statements? Hopefully the description that I just gave helps answer that question. But to repeat briefly, anytime you use first and last variables, you are looking to see what was the first time a variable occurred in the data set, what was the last time it occurred, right? And SAS cannot identify what was the first and last time it occurred if all of those values are not next to each other. SAS is not that smart that it can read the value across 25 different rows in a 1,000 row data set, which are not all next to each other, to identify what was the first time it occurred versus the last time it occurred. So you have to sort them, get those values all next to each other before you can use the first and last dart variables. Unfortunately, this is a requirement. This is not something that you can skip and expect first and last variables to work. So you have to sort the data set every single time you want to use first and last last variables. And the other thing that I will quickly reiterate is these first dot region, last dot region variables, they are implicit, right? They are hidden variables. They are always in SAS. You don't have to save them to an explicit variable like last underscore region in order to make the rest of the code work. You could have just written first dot region here, which we did in the following code where we use first dot type and last dot type, right? So you are welcome to use this and not use the explicit variable like this. It saves a little piece of coding. The advantage of using this explicit variables is that you can actually look visually in your data set. And I like doing that, especially if I'm learning how to do programming. I like to visually look at a variable, see the one number, see the zero values in there to make sure my code is doing what I want to do. So as you are learning, I would encourage you to do this and code it in explicitly. But once you become comfortable, maybe you can move on and just not do this. Instead, use first dot type and last dot type if you will. The last thing that I want to cover goes back to what Queenie mentioned earlier with her confusion about type 1 and type 2. I am positive Queenie is probably not the only person that got confused about that, right? I think that is a confusing concept. So in this question, what I want to talk about is how to think about buckets when you are sorting by more than one variable. So for this, I'm going to go back to my whiteboard. Okay, let me do this. So thinking about buckets in SAS, you have to be creative, but it helps your creativity if you can visually see what you're looking at. When you've got a data set that you are sorting, and you're sorting because you want them to be arranged in neat buckets. I don't like that row being messed up. Okay. Oh, what did I do? Oh, there we go. Okay. So when you are sorting a data set by more than one, when you're sorting a data set by more than one variable or more than one column, you have to understand how this sort works within SAS. If you've sorted or if you've played with Excel files for any amount of time, you probably already have an idea for how this works. But let's say you have person 1 in here 3 times, 2 in here twice, 3, then 4, just like we did last time, right? And then we have a second variable where we have A with A's and B's in there. Right. So this data set I'm showing right now is a data set that is sorted by 2 variables, the patient ID variable and another variable X, whatever it is, right? I have sorted this by both of them in an alphabetical manner. So row individual 1 comes first, then 2, then 3, and then 4. And then I sorted by X also, right? So this is similar to how you would say proc sort data equals something, and in the by variable you have more than one variable listed separated by commas. What happens when you list 2 variables separated by commas is this second variable gets sorted within the values of the first variable. So the A and B, you don't get a data set with all A's at the top. So all A's at the top and B's at the bottom is not what you get. You get this within each individual, right? So within individual 1, you get A's at the top, B's at the bottom. Within individual 2, you get A's at the top, B's at the bottom. Within 3, there is no A, so you just get a B. Within individual 4, there are no B's, so you just get A's, right? So the second variable in that by statement of a proc sort sorts the variable within values of that first variable. And you can use this type of sorting to basically create subgroups within subgroups. For example, let's say in this particular example here that you wanted to, you are interested in these buckets of individuals, which is individual 1, individual 2, individual 3, but you are also interested in buckets A, B, and C within each individual, right? And I'm using this example because this is something that we will come back to in this week's homework that I'm going to cover in just a little bit. Being able to use these 2 buckets, you can do a lot of interesting things, and you will find that you will almost need to do these nested buckets, if you will, when you're working in health outcomes research. So the outer bucket here is the individual. The inner or the nested bucket is this variable X within that individual. A good example of this is our homework, which hopefully by now you've tried, where we talk about drug name as the outer bucket, and then whether they are generic or branded drug, depending on the NDC, as being the inner bucket or the nested bucket. So outer bucket is drug name, inner bucket is generic name. So for each drug, you can have some generic NDCs and some branded NDCs, right? And NDC is the unit of analysis here in that homework data set. In our data set here, each individual is in here multiple times, and maybe the unit of the data set is office visit, right? So each office visit is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So each row is a different office visit, but sometimes those office visits are the same people. So while we have an ID variable for the visit here, this is the level of the data set, right? That office visit ID. But that's not how we are using the buckets. The buckets we are using are an outer bucket of ID and an inner bucket for the variable X. In the homework example, the level of the variable that the data set is set up with is NDCs. Each row was a different NDC. But after having each row as different NDC, the outer bucket we are defining is drug name, and the inner or the nested bucket we are defining is whether the drug is generic or branded, whether that NDC is generic or branded. Right? Being able to use these outer and inner buckets lets you create that incremental process with that retain statement that goes across the outer bucket if you want. It can go just across the inner bucket if you want. You can do a lot of things with this that basically will answer more complex questions, if you will, within health outcomes research. I say more complex, but really most health outcomes projects that I have worked on will need multiple levels of buckets. It's not just this outer bucket and you just use that to get to what you want. That happens from time to time, but very often I am interested in how many times somebody picked up a prescription from each pharmacy, for example. So then I'm interested in an outer bucket of each individual, how many times they picked up a prescription, and then the inner bucket of which pharmacy they went to pick up a prescription. So we may have a data set with 500 people where one person may have had 50 prescription fills, of which 10 of them were at pharmacy 1, 20 were at pharmacy 2, 30 were at pharmacy 3, right? And then we've now created these nested levels, if you will, nested groups or subgroups, where the individual was the bigger group and the pharmacy they went to was the smaller group. So if you want to identify how many prescriptions they picked up from each pharmacy that every individual in the data set visited, you will have to sort the data set by more than one variable, and you'll have to create these buckets or groups based on more than one variable. Does that help? Queenie, does that help with the confusion that you had earlier? I know you said it cleared up when you watched the video again, but hopefully this is also going to help a little more.
Yes, it did. Yeah.
Okay.
That's good. Thank you.
Okay. I'm glad to hear that. So let me switch gears now and go back into SAS Studio. Go back into SAS Studio, and I want to work on the homework now. I think we've completed everything that I wanted to show as far as the questions go. So let me switch gears and talk about the homework. Does anybody have any questions before we go there? Not hearing anything, but as I'm doing this, welcome to interrupt me. Okay. So here's the homework. What we needed to do for the homework, the first one, I had two objectives in the homework. The first one was basically to identify what was the average cost for every branded medication and generic medication within each generic name. When you approach that question, and the question actually was phrased as which drugs are more expensive, branded or generic ones. So when you approach a question like that, you have to automatically start thinking in terms of the buckets that we have to use, right? Let me go to the libraries here. Open the data set that we will be working with. Okay, so this is the NDC level file here. The unit of each row is NDC, but the buckets you are looking at each NDC has a particular medication class, but that's not the bucket we are interested in. We are interested in the generic name bucket, and we are interested in the GBO bucket, right? So if you want to compare average prices for each drug across brands and generic, the outer bucket is the generic name, the inner or the nested bucket is the GBO, which is brand or generic. So anytime you see that, the first thing that you will want to do is you should think, okay, the first thing I need to do is sort my data set. Because if you don't sort your data set, you can't use first and last dot variables. So let me go ahead and do that first. Using my out statement so that the sorted data set can be saved in a new file. I'm going to call my out statement just NDC. Then I have to sort this by generic name and GBO, just like we discussed. I think I've got a problem. Excuse me. The sort function does not have a comma between the variables. This is one thing. I've been programming for 8 years, but it still throws me off. I end up adding a comma where I should not. And then I look at my log and see the red underline and I go, oh, wait, I should not have had that comma. So let me run this again, this time without the comma. Okay, that worked. Now you see we've now the variables are not next to each other, so it's a little difficult to see, but you should be able to identify the dobutamine is the bigger bucket here, right? All the dobutamines are next to each other as far as we can see in these 100 rows that I can look at. If I click this button, I can see even more rows. But for now, let's imagine that the 100 rows are dobutamine. And within dobutamine, you'll see that the first few rows are all branded medications. That's the first 12 rows. And then everything else afterwards, the 88 rows are all generics. So we've sorted the data set by dobutamine first, and then GBO within dobutamine. So we've got that outer bucket of dobutamine and inner bucket of branded dobutamine and generic dobutamine. And if you go to the next row, let me scroll here, see if we can find a different example. So we have dopamine here. Dopamine has, I don't see any generics. Maybe there are only I don't see any brands, just generic versions of dopamine here. Lots of dopamine and NDCs. Let me see if I can find a drug that does not have as many rows so we can scroll through and look at it quickly. Doesn't look like we'll find one of those, huh? This is easier to show if I were working in real SAS because I don't have to scroll across the rows like this. In SAS, you just scroll top to bottom from row 1 to row 15,752, right? It's a little hard to do that in SAS Studio. Okay, here we go. I'm seeing, okay, so valbenazine, pharmacist on this call, I see Matthews on this call, he probably knows what that drug is. I do not know what that drug is. But valbenazine has just one row and that row is branded, right? So it got sorted after treprostinil and before valsartan, but there are no generic or brand NDCs, there is just one NDC, so that's where it sits. But within treprostinil, you'll see that branded ones are sitting here and there are no generic names within this drug either. So just branded drugs. And for Trandolapro, you see the branded ones are sitting up front, generic ones are sitting underneath them. So this is the smaller bucket within that generic name bucket. Okay, so hopefully the sorting is clear by now. So once we've sorted, we need to calculate average. In my homework and my exercise using the first and last dot variables, I did not show any of those things about how to calculate averages. I challenge you to do that on your own. If you were able to figure that out, that is awesome. Lots of kudos to you. If not, it's okay. It's understandable because I know I did not show how to do that. So let's do that right here. I'm going to create a new data set. I'm going to call it drug cost, and I'm going to set my NDC variable here. I'm going to write my work dot library just to be explicit. And before I forget, I want to make sure I add comments. Okay. The first thing you want to do when you want to use first and last dot variables right after the proc sort is to make sure you write the by statement in your data step as well. So I'm going to write the by statement exactly as I wrote it in my proc sort. And then it's time to write my retain statement. In my retain statement, I need two variables retained here, because the way to get to an average, if you think about this, is you first need to calculate the numerator and the denominator. The numerator in an average is simply adding up all the AWPs within each bucket we are interested in. And the denominator is a number of NDCs, right? Or the number of rows that we want to divide it by. So I'm going to create a variable called total AWP, which is the total cost or my numerator. And I'm going to retain another variable, which is the count or the denominator. Now, I could have written this in two retain statements. I could have written retain count, retain total AWP, but really I don't need to do that. I can write it in one statement, and as long as I separate my variables with a space, SAS knows what I'm doing. So, so I'm not really concerned about using two retain statements. I'm just going to use one here. Once I've done this, now it's time to start doing the AWP and the count variables. Let's do count first, because I think we've all seen count before. We know how it works. We just have to make it work here. I'm going to not create explicit variables. I'm just going to use the inbuilt hidden variables, first.gbo. And remember, when I'm doing the count, I can use first.generic name and first.gbo in this data step, but I'm using first.gbo because all of my analyses has to be done at the smaller bucket, at the level of the nested or the smaller bucket. At the level of the larger bucket, I'm really not interested, because I want to know the average cost of branded medications and generic medications within each generic name. So the level of analysis I am interested in is the smaller bucket. So I'm writing first.gbo, not first.generic_name. Okay. So if it is the first generic, if it is the first GBO variable we are seeing within a generic name, then I want the count variable to be set to 1. And if it is not the first GBO level, then I want the count variable to be set to count plus 1. Let me run this and we can quickly look at what we have to make sure that the code worked okay. I like doing this every time I write something that, if I'm not sure how it works, before I go on and finish the data set, I'll run just that part, hit run, see if it ran without errors, and see if the code final output looks okay. So in this case, in the final output, I just want generic name. I want GBO, and then I want my count variable. All right, so within dobutamine, these are the brands for the first 12 rows, and then generics afterwards. So let's see if count works. There you see. So count incremented from 1 through 12, which was for the nested smaller bucket. And then count reset to 1 when GBO changed from B to a G. Right? So now we have a count of how many NDCs or how many rows occurred for branded dobutamines. And then we have a count for how many occurred for generic dobutamines as well, if I go to the bottom of the dobutamine column, which is where did that go? Okay, 88. So this is the last row of the dobutamines. And for the last generic dobutamine, you'll see there are 88 NDCs or rows for the dobutamine generic medications. So this is my denominator. This is what I'm going to be dividing it by to get my average. Now let's do a numerator. For the numerator, wait, before I go there, okay, the numerator is total cost, because when I'm calculating that average, I want total cost in the numerator before I divide by the number of rows. And the way to calculate total cost is to do exactly what I've done with the count variable here, but instead of incrementing each row by 1, I want to increment it by the AWP variable, right? So if first.gbo, then I'm going to call this variable total underscore AWP. I'm going to set for the first row, I'm going to set it to AWP. And then I'm going to start the incrementing process where we add that value of AWP only when it is not the first row. Does this make sense to everybody that's on the call right now? Okay, got a couple of thumbs ups. Thank you. Okay, so let's see if this works. Let's look at it before we finalize that this is our homework score. So here is my count variable. Where is my total cost variable? Well, the total cost variable is not here because I left it out of my keep statement. So let me add AWP and total AWP to the keep statement, and then I can actually look to see if it works. Log looks fine. If you look at my output, okay, so you'll see here the first 12 rows are branded dobutamine. You'll see that the total AWP is basically taking this number one. So for the first row, total AWP was just equal to AWP, so it is 120. For the second row, it's 120 plus 12, which is 132. For the third row, SAS remembered because of the retain statement that it has to take 132 and then add that to 12, which is 144. And then 144 plus 120 is 264, so on and so forth. And it got it up to 792 here, which is the last row of the brand sub bucket within the dobutamine bucket. So for the next bucket, for the generic names, total AWP gets reset. That incremental process does not happen, and total AWP nearly gets set to the AWP column, which is 59.38. And then it gets added 59.38 plus 260 is 275.38, 275.38 plus 31.3 is 306.68. So that incrementing starts again. Does this make sense? So now we've got a numerator column and a denominator column. But remember, this is only the numerator for the last row of this bucket. This row number 12 shows us the maximum value of count, which is the total number of rows, and the maximum value of total AWP, which is the total cost of all NDCs within that bucket. All of these numbers before it are really meaningless, right? I have nothing I want to do with those rows. In fact, if I use those rows, I might end up with incorrect numbers, because if I think, for example, that 4 is the correct number, and if I use that as the denominator for my average calculation, my average will be off, because the average should be calculated with a denominator of 12, not a denominator of 4. So these rows before that last one, those values now are absolute gibberish. I don't want them. I want to delete them. And I want to delete every row I want to delete every row in this data set that does not have the last value of the smaller bucket that I'm interested in. One thing to remember when you're doing this is that when you delete these rows, you will lose a significant amount of information, right? When you delete all the other rows, any information present in this other rows will be lost. You cannot get them back unless you rewrite the code to save them. So that's okay to do, but you have to keep in mind that if you are losing variables, make sure these are variables you don't need later, right? And if these are variables that you do need later, maybe you should be summarizing them along with numerator and denominator here, as opposed to just not doing that. Now, the other thing to remember is that if you are holding on to just the last row of the smaller bucket, then please get rid of any other variable that is meaningless, because right now this last row, that has the numerator and denominator, which are the correct values, right? These numerator and denominator values before it are meaningless. Just like these are meaningless right here, the AWP variable for the last row is absolutely meaningless, correct? So the AWP variable for this row is 120. All that is telling you is what is the cost, the average wholesale price of that NDC in that row of data. But really, once I've gone to these summarized columns with the total AWP and the count, our numerator and denominator, what do I even have to do with this number? This 120 is absolutely meaningless, just like the number 4 was meaningless for a variable for this row earlier, right? So once you've used the retain statement to summarize and add, you do want to hold on to that last row of a bucket, but then every other variable that you're not summarizing is meaningless. The only variables that are meaningful when you hold on to that last row are the variables that are used to define your buckets, which in this case are generic name and GBO, right? This one and this one. And then the numerator and denominator, which are your summarized variables. So besides the bucket index variables, if you will, the variables that you're grouping by, and the summarized variables, which is total AWP and count, every other variable is meaningless. So if you are going to write a code here to say if loss.gbo then output, then take out variables like AWP, those from your keep statement, because those variables are not meaningful anymore. Let me run this. Check my log. Here's my output. Okay, so now you see the data set begins to look so much clearer. We went from 15,000 rows to 256 rows. Dobutamine has a brand and generic, and total cost of all the brands of dobutamine is 792. The total cost of all the generics of dobutamine is 28,540. If you look at just that number and you say, oh, wait, why is generic costing more than brand? Well, that's because there were 129 generics for dopamine and only 12 brands for dopamine, right? So we haven't taken the average yet, but we have summarized the cost and number of NDCs. And you can scroll across this data set to do this for any of the drugs, right? So you can see that ephedrine here has brands and generics. The total cost of brands for ephedrine is 1462. Total cost of generics is 6863. And you expect to see generics as having a total cost number higher than brands here, because there's usually more generic medications out in the marketplace than there are brands. But when we take an average, that should change. Let's look at one more example, caffeine. Caffeine has brands and generics. The total cost of brands is $22.89 and the total cost of generics is $37.07. Total number of rows for brands for caffeine, or total number of NDCs, are 36 for brands and 58 for generics of caffeine. So now you can begin to see how this works. The last thing we need to do to make our homework completed is to basically calculate the average. So I'm just going to write a new line of code for that. I'm going to say average AWP equals total AWP divided by count. This is simple and this will work, but if you read the homework, we say that we only want the average up to 2 decimal places. We don't want anything more. So let me use the round function. And I want to round up my numbers to the closest 0.01. So everything is rounded up to 0.01, which is 2 decimal places. Before I run this, can somebody tell me if this will work? I'm taking bets on if this code will work or not. I got a thumbs up from Queenie. Queenie thinks it will work. Shishir, you have an idea?
I think it won't work.
Okay, can you tell me why?
Because there is already output statement in there.
Perfect. That is absolutely the right answer. Let's look here. So here's my log. Log tells me it worked, right? The log does not give a problem. But if you look here, well, I did not keep my average AWP variable. I'm sorry. Let me hold on to this. The new average variable that I just created, I want to add that to the keep statement. Run it again, and you'll see it won't work. Shishir is absolutely right. You'll see it's missing. It's missing even though log did not throw an error. And that's the tricky part about SAS. You have to check your data set to make sure it works. You can't just look at the log and say, all right, my code worked. I don't have to worry about anything now. You have to look at the log, and then you have to check the data set. And the average AWP did not work. We have missing values here because the output statement was written before my variable was calculated. So let me just cut this output statement and paste it here, and now it should work. So Shishir, good catch. And if you missed that, that's okay. This is the kind of thing that you will learn by practicing. And while I'm on this topic, Shishir, I have to say, shout out to you. I really appreciate you working through the homework every single week and then giving me an update on actually how the videos were and how you completed the homework. Please continue doing that. And for everybody else, I will appreciate it if you do that as well, right? So thank you.
Sir. Yes.
Okay, so we've now calculated the average. Let me check the output data set. Okay, so the output data set now tells me that dobutamines for brands, the average cost is $66. And for generics, the average cost is $221. And if you think that is weird, I think that is weird too, but I don't have an explanation for it. This is a fake data set. Just go with it. Hopefully for most other drugs here, the numbers look reasonable, which is to say that brands are more expensive than generics. Let me scroll to another example and see if it works. Let's take benzoamphetamine. I did not even know there was a drug by that name, but here are my brands. So the brand's average cost is $260. The generics average cost is $152. which is what we want to see, right? Now we have not covered how to do some summary statistical functions like means, medians, and minimum and max. We will do this in week 6. So for now, we are just going to visually observe our data sets and see if brands are more expensive than generics. But I will teach how to calculate the means and the average and standard deviation in week 6 of this bootcamp. All right, so we've got the numbers we need, but the homework actually asks that the data set be set up a different way. So this is good, but the last thing we need to do, we need to transpose our data set. Before we transpose it, I want to make sure we only have the variables we need in this data set. So I'm going to remove my numerator and denominator variables, because the only variable I need to see at this point is name of the generic drug, whether it is brand or generic, and then what is the average cost or average AWP. I don't want any other variables in my data set. And then the last thing I need to do is I need to write a proc transpose. Let me scroll here so you can see. Proc transpose data equals drug underscore cost. I need an out statement because the transpose data set have to be saved in a different data. I'm going to call this one GB of cost. You can call it anything you want. Now, the variable that I want to transpose is the average underscore AWP variable, right? Now, I want to transpose it so that when the transpose is done, the data set has to look something like this. Let me go to my whiteboard. So right now, the data set looks like this. So you've got generic name A, brand, generic, dollar amount 1, dollar amount 2. Drug B, brand, generic, dollar amount, dollar amount. This is what my data set looks like right now. This is generic name. This is GBO. This is average cost. I want my final data set to look something like this. I want to have A. I want to have cost for the branded drugs, cost for generic drugs. So this is dollar, dollar sign. And then B, cost for branded drugs, cost for generic. This is what I want my output data set to look like. I don't want this format. I want it to convert to this one. So while it might not appear like that at first glance, this is a transpose. This is a transpose because we are taking this column, which is one column, 2 rows, and we are transposing that into 1 row, 2 columns. Right? We are transposing this column right here. While transposing it, we are making some other changes. We are taking the drug A from 2 rows to 1 row, right? And the name of these variables, the name of the variables, brand and generic, are coming from the value of GBO. Right? So it is a simple transpose, but it is transposed with some other complications in there. So this might not look like a transpose at first glance, but once you've seen enough transposes and enough data layouts and data structures, you will begin to identify that these are in fact transposes. It's just a little more complicated to do this. And the reason I'm making you do this transpose right here is because if you want to use a summary function like mean, for example, if you do a mean on this variable here, that number will be meaningless, right? If I wanted to compare branded and generic drugs, then I want to take a mean of all the brand values and then a mean of all the generic values. If I just do a mean on this variable, that does not give me what I want. So I want a different variable for brands and a different variable for generics that I can do an average for. And that's what this new data structure allows you to do. That's why this transport is important. I'm not just making you do this because I want, I'm making you do this because I want you to practice proc transpose, but I'm also making you do this because most statistical procedures will require you to set things up this way. Let me go back to SAS Studio here. Okay, so I am transporting my average cost variable, but as you saw, I am transposing it within each generic name. So I'm going to say by generic name. Right? Is there anything else I need to add? Can somebody who's done the homework or worked on it tell me if I'm missing anything?
Like ID function for holding GBO.
Perfect. Thank you, Shishir. The ID function is missing. Let's first run it without that ID statement. see what happens, and then we can go back and add the ID. Log looks good. Output data. So now I have generic name. I have a new column called name underscore, which is what SAS does every time it transposes it. For now, I can ignore that because I've only transposed one variable. But I have a COL1 variable and a COL2 variable. Now, I know because my data set was sorted that the first column is the first row it found, which is the first row was brand, and the second row was generic, right? So COL1 I know is brand, COL2 I know is generic. And I can use a simple rename function to rename them, but instead of me doing it manually, I can do it within the code, and I can get SAS to do that work for me by writing an ID option. So here we have it. So now we still have dobutamine, which only has one row now, as opposed to two rows in the previous data set before the transpose. We have a brand name here and generic here. And that's what we want, right? This is perfect. Now, if you want to get a little finicky and if you want to get picky about how to do this, you might want to change this up a little bit, right? I want to see a prefix, for example, where I want to say prefix will be average underscore AWP underscore. I'm going to end the name of the prefix with an underscore so that the B and the G get added to the end of that prefix. So average AWP for brands, average AWP for generics. Now, if you want to get even more picky, one thing you can do is you can rewrite the brand and generic variable name. So you can say, if in my previous data step, I can say if GBO equals B, then type equals brand. If GBO equals G, which is generic, then type equals generic. Right? If I write this and then instead of my GBO variable, I hold on to my type variable. Well, let me also do this. And then I will change my ID statement from the GBO to the type variable. And if I run both sets of these steps together, you will see I now have a problem. Let me see if this works. This is why you should not run too many steps of code at a time. Let me run it one after the other. My type variable is missing, even though I wrote it in here. So what's going on? If GBO equals G, then type equals generic. GB equals B. Oh, I had probably. I'm going to use my uppercase operator. I could have used lowercase here, but I'm going to use my uppercase operator. I am also concerned there may be leading or lagging spaces in my data. So I'm going to use the strip function just to make sure there are no other problems. So what this is doing is it is going to strip the extra spaces from my variable after it converts everything into an uppercase. Hopefully this should work. No, that also did not work.
Is it because it's below output statement?
Thank you, Shishir. I don't know why I keep doing that. Thank you. Good catch again. All right, now it worked. There you go. Shishir, thanks for catching that error. So now I've got brand and generic. Now if I use this new variable, which is type in my proc transpose, okay, now I've got more descriptive names. I've got average, AWP, and AWP actually is average wholesale price. So I realize average is redundant there, but it's the average AWP for brands and average AWP for generic. And now I can look and compare across the columns for each drug that I'm interested in. So I can look at amphetamines, and I can see that brands cost $526, but there are no generic drugs for amphetamine in the data set that I've provided you. So on and so forth. In week 6, we'll talk about how to take a mean of this column, and then actually do perhaps a t-test between those means to compare these drugs to each other. Right? That should complete objective 1 in your homework. Any questions so far? Okay, I'm not hearing anything. I'm going to add some comments. Let's move on to objective 2, and this should be the last thing we should cover, so hopefully we can wrap up in the next 15 minutes or so. For the objective 2, what we need to do is identify how many months it takes to pay off a single medication if an individual is doing monthly installments, monthly payments of $10 for every single month. Then how many months does it take to pay off this drug? For that, I'm going to say, let's write a data statement, call my new data set monthly payments. My set statement, I'm going to set my NDC data set. Actually, I'm just going to use my work data set, work.ndc. So to do this, let's go back, open the data set, and talk about how I would approach a problem like this first, and then we can talk about how to write the code for it. Okay, so here is my AWP column, right? So if I were to pay $10 monthly installments, I can just look at this number and tell you that should probably take 12 months, right? And this $12 drug will probably take me 2 months because I pay $10 the first month and the leftover $2 in the second month. And then this $58 drug will take me 6 months, right? $50 in the first 5 months, $10 per month, and then $8.309 in the 59 in the 6th month, so that now I'm paid off within 6 months. So I can simply get at my number by dividing the AWP column by 10 and adding 1 if it is not a perfectly divisible number. I could have done that, but the code, the homework tells me don't do that. Instead, I want you to use the do loop with the do while or a do until loop actually in order to complete this task. So let me go ahead and start doing it that way. But in order to help us with the do loop, the homework actually says that there is a maximum of 36 months in which every single drug has to be paid off. That maximum actually did not need to be included. The only reason I left that in there was to help you with your do loop, so that when you set your counter variable in your do loop, you now have a minimum and a maximum. Now the minimum is just 1, right? Every single drug can be paid off in 1 month at the very least. Nothing can be paid off in 0 months. So I'm going to set my counter variable to loop from 1 all the way to 36. Why 36? Well, 36 because the homework says that the maximum number of months you can take to pay off this drug is 36 months. And then I want to write a do end statement. And at this point, I just want to do a loop where each month we pay 10 more dollars, excuse me. So I will take the paid value and I will add 10 to it. So let me first set paid amount to be equal to 0. Got a lot of typos today. Initial paid amount equal to 0. Then we have loop to So what I'm doing here is I'm looping through each month, right, up to the maximum number of months, and then each month I'm going to increment my paid amount by $10, right? So every month the paid number goes up by 10, and that's it. That's all I need to do. If I do this, I should be able to see the paid amount go up every single month. Let's run through this. Check my log. My output has too many columns. Let me use a keep statement. I don't want to be scrolling through all those columns. The only columns I'm interested in right now are the AWP column, the paid column, and the I, my counter variable. Now let me hold on to my NDC code variable just so that I have an ID to look at. Log looks okay. Output. So here's my NDC, which is like my ID variable in this data set. Here's my AWP. So AWP is 120. but the paid amount is 360, right? And I is equal to 37 for every single row. Why is this happening? Somebody that tried their homework, can you tell me why every single paid amount is 360 right here?
You have not set any condition right now.
Okay. Shishir,
Yeah.
you are absolutely right, but I want to see if somebody else can also speak up. Is that okay? I trust you know the answer, so don't take it the wrong way. I'm just trying to see if somebody else can share the answer as well.
Sure.
Okay. Can somebody else tell me what is going on? Why my paid amount is 360 here? I'm not trying to put anybody on the spot. I promise this is very difficult for me to do in an online environment, to look into a screen and talk, and trust that you all are listening on your end. If nobody knows, you can just speak up and say you have no idea, and that's okay. I'm not putting you on the spot. So let me repeat my question. Why is the paid amount 360 here? This is the code we wrote, right? Why is the paid amount 360 for every single row in this data set?
You didn't set a condition to stop, like when it was actually paid. It just multiplied by the maximum amount.
Thank you, Dr. Yang. That is very helpful. I appreciate you speaking up there. So that's exactly right? What is happening is that the paid amount keeps incrementing by 10, 36 times. We are looping this 36 times, and that number 10 gets added all 36 times. So for every single person, we have a paid amount equal to 360, which is not what we want, right? Why do you want to keep paying after the AWP has been met? So we want to add a while or an until condition. So let me add an until condition, for example. You want to keep doing that loop until paid is equal to or greater than AWP. Now, sorry, I've done equal to or greater than AWP. The reason I did greater than or equal to instead of just equal to is because we are adding by 10 every single month, but sometimes there may be less than 10 months, that $10 that need to be paid, right? Sometimes maybe the amount you need to pay is just $1 or $2. So if you add 10, you will overshoot the amount that you need to pay, and then I'm afraid that won't trigger the condition. So in order to be safe, I just want to write the greater than or equal to, so that whether or not $10 actually meets the AWP or it overshoots it, the condition will still be met. So if I do this, what this is saying is as soon as the condition is met, the loop will stop running. When the loop stops running, the final amount of paid should reflect how much money is actually paid for each drug. So let me write my run statement. And there you see, so now this, for the first row where AWP was 20, the paid amount stopped at 120, and the I actually betrays how many loops were run. So for this first row, after running 12 loops of the code, we reached the value where the condition was triggered, where paid amount was greater than or equal to AWP. So we know that 12 loops were triggered, where 12 loops were executed in order to get paid to be equal to AWP. For the second row, where the AWP is 12, the paid amount is 20, because remember, we are incrementing by $10 every month, so we overshot how much we had to pay, but we got there in 2 loops. So the I here, which is the counter variable in our do loop, actually is a way to give you a hint of how many months of payment you need to make of $10 each to get to that AWP, right? So this I variable is in effect the number of months you need to make payments, which is the objective of this second homework. So if I want to finish my homework, I've already completed all of it. All I need to do is I need to set the I variable to be equal to number of months. So I can do that right after my do loop is completed, because I don't need to do it within the loop. I can just say number of months equals I. And that should be, wait, let me add this to a keep statement. I keep forgetting to do that. That should be everything I need to do. So it takes 12 months to pay off the first drug, 2 months for the second drug. If you scroll down, you'll see for some months there is actually 37, and this is an error, right? Because I mentioned in my homework that the maximum number of months is only 36. Why is this happening? Well, so for some of these NDCs, the cost is actually greater than 360. And 360 is the maximum you can pay if you pay 10 months each for 36 months. So when you hit 360 and that condition in that until clause is still not triggered, the loop stops running, but I automatically gets incremented to 37, right? So these are those scenarios where when you are in SAS and you're working through this code, you will feel like your code did everything you wanted it to do. Your log looks perfect, but unless you scroll and visually inspect your data, you might not catch cases like this, right? So you have to scroll through it, make sure everything looks okay. The easiest way to do that is once we learn how to summarize a variable, you can run some mean, standard deviations, minimum and maximum on the variables that you just created and make sure everything looks reasonable. That visual inspection is very, very vital to know you don't have any errors in your code. And as someone that has had a lot of errors in their code, as Dr. John Young will tell you, this is something that is very, very important. So now that we've identified the error, let's fix it. Let's just say that if number of months is greater than 36, then just set number of months to be equal to 36. This is one simple way to do it, right? If you don't want to write an if-then statement, another thing you can do is you can use the max function, which I have not talked about so far. Sorry, not the max function, the min function. What the min function will do is it will basically select the smaller number out of all the numbers that you feed it. You can feed 50 numbers to a min function and it will pick out the smaller number. When I use the min function in this case, what I'm telling SAS is take the smaller value of I or 36. So if I, the number of months that you're paying or the number of loops that you ran is less than 36, then set that value to be equal to number of months. But if I actually goes up to 37 because you ran through all 36 months, then don't set number of months to 37, set it to the smaller of the two values, which is 36. Right? So this is one way of saying this should be my upper limit for the number of months variable. This will accomplish the same exact thing as my if-then statement here. It's no difference at all. It's just a more efficient way to do it, if you will. Because when somebody else is reading your code and they see a min statement, they can see what you're doing is you are setting a maximum value to your number of months variable. If you instead use the if-then statement, it looks like you're artificially changing the number of months to 36, and people might wonder why you're doing that. So I would encourage you to use min statements if you can, but whenever you do things like this, also write your code, write a comment explaining why you did that. Log looks okay. I'm going to check my output data. There's my number of months. Let me see if there are any 37s here. No, there are not. Okay, so this row, for example, where I went up to 37 because all loops were completed, the number of months variable is equal to 36 now. So I can go ahead and drop my I variable from my keep statement, and that's it. I've got the answer I need. That's homeworks for Objective 1 and Objective 2 for week 3. Any questions? We are right at 90 minutes today, so we've taken the full time. I just want to reiterate that you've made it halfway through this boot camp, so I already am very proud of you all. For those of you that have finished it and have completed your homeworks, hang in there. We've got one more week of, I think, what I would say is challenging content, and then this gets super easy one more time. Next week will be a little bit challenging, and it will take time and practice. But after that, things will get easy again, and you will wrap up this bootcamp before you know it. If you don't have any more questions today, then I'm going to say we can call it a day. I hope you watch Hamilton today, and I hope you enjoy your long weekend. Thank you for being here.
Thank you so much. Thank you.
Thank you.
Yeah. Thank you very much.
All right. Thank you all.
Bye-bye.
Have a good long weekend.